your practice final. We're going to start with number 16. This one requires a little bit of work here because we have to find the possible rational zeros and then find all the actual zeros. So when we did the possible rational zeros, this number right here, that one, that's your P, and this is your Q. So we set it up as P divided by Q. So all the factors that give you this over the factors that give you this. Well, aren't they going to be basically the same, just positive and negative 1 and positive and negative 3? That's going to be the same up top and on the bottom. So when you do this, the possible ones, okay, so watch. 1 divided by 1, 1, right? The 3 divided by 3 would also give us 1. How about 1 divided by 3? Wouldn't that just be 1/3? So we have positive or negative 1/3. And then what about 3 divided by 1? So positive or negative 3. Yep, those are our possible zeros. Okay, so now to find the actual zeros. Do you remember how to do that? We do synthetic division using positive 1 first. And if the positive 1 doesn't leave us with a remainder of 0, we do negative 1. So we have 3, 11, 5, and negative 3. And we're going to use the positive 1 first, see what happens. 1 times 3 is 3, then you get 14. 1 times 14 is 14, then you get 19. Now look, I already know this is not going to give us a remainder of 0. That one's out. So then the negative 1 should work, but we still need to know what numbers would be at the bottom, because that's what we're going to use to factor. So I'd have 3, 11, 5, negative 3. This time we're going to use negative 1. So when we multiply this out, negative 1 times 3 is negative 3. You add, you get 8. Negative 1 times 8 is negative 8. You add, you get negative 3. And negative 3 times negative 1 is positive 3. You add and you get 0. So we would have 3x squared plus 8x minus 3. That is what we get from here when we factor. So we've got to make negative 9 and positive 8. Well, it's definitely not 3 and 3. 9 and negative 1. Now, doesn't this one over here reduce to 1x plus 3? So I have x plus 3, and then my other one is just 3x minus 1. This one's easy to go straight to your answer because that would just give you a negative 3. The other one, though, is going to be a fraction. You add 1 and then divide by 3. So you get positive 1/3. Okay, so you're... Yes.
Okay. I'll read on the bottom.
What, here?
Yeah.
No, that was 3x plus 9.
Okay.
This is me just crossing it out when I reduced.
Okay, guys. Good, one in the middle.
So when you write your actual answers, we have the -3, we had the -1 from when we did synthetic division, and we have positive 1/3. So there were 6 possible, and there were 3 actual. Now this next one, I'm going to make a little table here because it just says, all it says to do is determine the end behavior. So remember when it says determine the end behavior, they want to know what happens as x approaches negative infinity and when x approaches positive infinity. They want to know what happens to the y. Okay, so now, we don't even have to graph this, and we should be able to figure it out because, remember, when it's x to the third, it's either start low and end high, or it's start high and end low. When it's negative x to the third, what do you guys think it is? If it's negative, negative means decreasing over time. So, and look, this is not what it's actually going to look like. I'm going to do a real quick sketch. I mean, it would do something like this. I know that when it's negative x to the third, that's the kind of shape it's going to go. Now, if it were positive x to the third, okay, I'll do that one because I don't know which one you'll have on your test. Let's just say it was positive x to the third. Then the graph would go like this. It would do something like that. So what's happening here? As I go negative on the x, what's happening to the y? As I go this way, it's going up. So that approaches positive infinity. And as I go to the right, which means as I go to the x positive, what happens to the y? It goes towards negative infinity. Now, if we were to do this one over here, if it had been positive x to the third, as x approaches negative infinity, doesn't y also approach negative infinity? And as x approaches positive infinity, so does y? Yes. Yeah. So it just depends. You know, tomorrow when you guys take your final, be on the lookout. If it's negative x to the third, it would go high to low. And this would be the answer. If it's positive x to the third, it goes low to high. Still holding it down. Yep. You guys good with 17? Caleb, you good? Okay. Well, number 18 is division, so that's going to be a keep, change, flip problem. So So we don't ever leave those as division. What you do have to do is factor anywhere you can factor. Well, this top right here is the only one that factors because it's the only quadratic. It's the only one that has an exponent. All these other ones, they're not going to do anything. So we're going to have two sets of parentheses, but then the x plus 2 stays the same. Division changes to multiplication, and then make sure you flip this side. So 7x goes up, x minus 9 goes down. All we have to do is figure out the two sets of parentheses for the negative 18 and the negative 7. They're not both negative. You would not have a negative up here if they were both negative. Yeah, negative 9 plus 2. So x minus 9 and x plus 2. Whole bunch of stuff cancels out. What cancels? And? Yep. Only thing left? 7x. Now, anytime you have a square root, like a problem that involves a radical, the radical has to be, so Brittany, this is what you were thinking of before. This needs to be isolated before we can square it. So we're going to move the minus 10 by doing, we're going to add 10. So negative 5 plus 10 is 5. Equals, and then we bring down this radical expression. And then to undo a square root, we raise it to the second, and if you do that on the right, you have to do that on the left. Okay, so 5 squared is 25. Now the right side, the symbol just disappears, right? So it's just negative 1 minus 26k. And then it's just two more steps. We're going to add 1 and then divide. And when you take a positive 26 divided by a negative 26, you get negative 1. And then that one's done. All right, problem number 20. All they want us to do is put this into radical form. Okay, so look, this is the exponent, this is the root. So all you do is you stick that x squared under the radical. You'd have a power of 1 out here, and the root is 6. That's it. When we do inverses, this becomes the letter y. And then we trade the x and the y. So I'd have x equals the cubed root of y plus 3 minus 1. And now our goal is to do as many steps as it takes to get that y by itself. So what am I going to move first? Add 1 to both sides. So we have x plus 1 equals the cubed root of y plus 3. How do we get rid of roots? Yep, we raise it to the third power, which we have to do over here as well. So we have x plus 1 to the third equals, and then the root cancels out, or the power cancels out the root, so it's just y plus 3. One more step. What do I move? Subtract the 3, and it does not pair up with that 1. You just write it sideways. X plus 1 to the third minus 3, and then instead of putting equals y, we put that function notation, the g of x, but since it's the inverse, you got to have that little -1 as the exponent in there. So g with the exponent of -1 of x. That just means inverse. Okay, now, this is a piecewise function. Number 22. The 1, this one right here, that's the one that each T-chart should start with. Now for the numbers less than 1, so you might want to be looking up at the board. For the numbers less than 1, we're going to use this to find our y's. So that would be like 1, 0, and -1. Those are the ones that are less than 1. We're going to use x plus 2 to find the y value. Okay? Now, is there an equal sign with that less than symbol? No. So my first circle here is going to be open. If you plug in a 1, what's 1 plus 2? 1 plus 2.
Oh, 3. I'm sorry.
0 plus 2.
2.
-1 plus 2.
-1.
It's positive 1. Okay, so I'm going to go ahead and plot those. So at 1, 3, you've got to make an open circle. Now 0, 2, and -1, 1. Those do not need to be open. You just make those solid points. Okay, now because they're decreasing, you're going to start at that open circle, and you are going to just connect those points. That's one piece of the function. Now for the other one, since these are going to be greater than 1, so like 1, 2, and 3, we're going to use -x minus 3 to find the y values. Okay, so I would do the opposite of this, so that'd be -1, minus 3 is -4. And because of this, because there was an equal sign, that one's going to be a closed dot, closed circle. -2 minus 3 is -5, and -3 minus 3 is -6. So you're going to start at 1, -4, 2, -5, and 3, -6. And all of those are closed. You just connect them and draw the arrow. That's your piecewise function for number 22. All right, number 23. They want to know, well, first of all, it says Identify the transformation, then sketch the graphs of both the parent function and the transformed graph. Okay, so remember the parent function, since this is a square root, the parent function is just square root of x. So before we do anything else, remember when it's the square root, we just use the 0, 1, and 4 because we can take the square root of 0, which is 0, square root of 1 is 1, square root of 4 is 2. And that's all that'll fit because it doesn't go out to 9. I like to go ahead and graph my parent function first, and then we'll worry about the transformation. Okay, so 0, 0, 1, 1, 4, 2. So square root should always kind of look like that. Now, when we talk about the transformations, we've got two of them. We've got this one and this one. The one paired with x is the horizontal, so that's either left or right. Yep, because you always have to think opposite. So left 3 units, and then the one out here is always the up or down, and that one's always the same. Down 2. Okay, so all you're going to do is you're going to take those 3 points that I plotted, and you're going to move each one to the left 3 and down 2. So I'm going to do that in a different color. I'm going to go left 3 down 2, left 3 down 2, and left 3 down 2. So then you've got the transformation is done in purple, the parent function is done in green. The one on your final is the square root also, so it's going to be similar to that. It may have one transformation or it might have two, but good? You got it?
Oh, what, me?
Mm-hmm.
Yeah.
Okay. I just didn't want to move on if you weren't ready. Okay, 24. This is an exponential equation. So remember, to solve exponential equations, they have to have the same base. Well, can't we make 64 8 to the negative second? Or, I don't know why I said that. 8 to the second. Let me get rid of that. I don't like that. 64 is 8 squared, right? Now 1/8 is 8 to the negative first, because remember when it's a negative exponent, it just means flip it. Yeah? So whatever exponent was there, we have to keep there. You just attach it to that -1. And whatever exponent was over here, we have to keep there. You just attach it to the 2. And now that since they have the same base, we don't have to use the bases anymore. We just set exponents equal. So we're going to do this. We're going to take this and set it equal to this. So that would be a -2a equals, and then we distribute over here, -1a plus 3. That's a real simple equation to solve. All of my a's have to go to one side. So I could like add 1a to both sides.
Yes.
Okay, so that'll give me a -1a equals 3. And then we just divide by -1. So a is -3. Done. Number 25 was a log equation like we did on Thursday. So we had talked about the properties of logs, and we had said that when it's subtraction, what does subtraction get turned into? You weren't here for this. Caleb, do you remember what subtraction gets turned into?
Addition?
No. Addition gets turned into multiplication. Subtraction gets turned into division. So since they have the same base, we're going to condense them down to one single log. So it'd be log base 6, and then in parentheses, you'd have x minus 3 divided by 2. So it's just this divided by this. And then the other side, just keep the same. It's okay. Trust me, I know. All right, so then, now that each side has one log with the same base, look, remember how over here we didn't need the bases anymore once they were the same? Well, if these are the same, you don't need those anymore. You just set it up as x minus 3 divided by 2 equals 12. And we're going to solve that. So if on the left side they divided by 2, what do? Multiply both sides by 2 to get rid of it. So we have x minus 3 equals 24. What's my last step?
Subtract 3.
You sure about that?
Or add 3, I'm sorry.
Add 3. So x equals 27. Done. Brittany, honestly, I think that problem's the only one that you missed on Thursday. Like all the other ones you were here for. It was just one problem from one of those
I
lessons.
say that one was a little confusing, but not that hard.
Okay, so 26 says use a calculator to approximate the answer to the nearest thousandth. Okay, so that means, remember, you can't type this directly into the calculator because it's not a base 10. So you have to do the change of base. Do you remember how to get that set up? Log of what divided by log of what? Log of 2 divided by the log of 7. The base is always on the bottom. .356. 0.356. Done. So yeah, that's just a change of base. And number 27 is even easier because 27, they just want you to go from log form to exponential. So all you have to do is tell me which number represents my base.
169.
Base.
13.
13's the base, the exponent.
2.
And then the y value is the 169. So you go from log form to exponential. So the base to the exponent equals this. And then when you're ready, turn it over. We've only got, what, 2 problems on the back, I think? 3 problems?
Yeah, 3 problems.
Okay, these are the last 3. Now, 28. 28 is kind of difficult. So, no, I lied. So this one you missed on Thursday also, because this is properties. Okay, so first of all, let's talk about this. Inside those parentheses, that is 3 times. Now, if I told you guys right now, I want you to write that in exponential form. Remember, the 7 would be my base. My exponent, the root is 3, and if there's no power, it's a 1. So that's 7 to the 1/3 power. Okay? So now, Caleb, remember how you said multiplication gets turned into addition? Okay, well, that's what we're gonna do. We're gonna expand this. So my first log is gonna be for the 3. So I would write log base 4 of 3. You're not solving anything, we're just expanding. Then since it was multiplication, we're gonna turn this into plus. You would write log base 4 again. Now this time it's for the 7, but where do exponents move? Caleb, do you remember where the exponents move?
The 3 goes,
No, the whole 1/3, where does it go?
oh. The side, oh,
Goes in front.
yeah, I don't.
1/3 would move in front of the word log. If you have an exponent, it goes in front of the word log.
Okay. This is confusing.
Now, there's a lot of stuff. That's it. So you were just expanding. Now, honestly, 29 and 30, I do not remember there ever being lessons in the new curriculum unless I'm just crazy. But I know I did not teach you guys completing the square, and I did not teach you vertical and horizontal asymptotes. Now, I do that with my Math 136 students.
I don't remember this.
We didn't do it. Now, they are on the final, so they were supposed to have been done at some point, but I guess we just didn't get there, or I don't know. I don't know where they went, but I'm going to show them to you, but I can tell you right now that they are going to be bonus problems on your final. So these are going to be bonus because we never did have lessons on either one of these. Okay. So I'm going to show you how to do it. Okay, first of all, in order to complete the square, normally I tell you guys to bring this 7 this way, right? And then we would factor. Well, completing the square is done a completely different way. This constant needs to move this way. So we're going to add 6 to both sides. So we have r squared plus 12r equals 13. Okay, now watch. Completing the square, we are going to add something to both sides of the equation. And what that something is half of this. So what's half of 12? 6. So half of 12 is 6, and then you square it. What's 6 squared? 36. So we're going to add 36 to the left and to the right. Now, the reason we do that is because, okay, now watch. This right here would be r plus 6 times another r plus 6. Because look, 6 plus 6 is 12, and 6 times 6 is 36. So that's how it would factor. This side would be a total of 49. So when you have two of the same sets of parentheses, can't you write it like this? R plus 6 squared equals 49. And how do we get rid of squareds? We take the square root. So this side would just become r plus 6. Now, the other side, the square root of 49 could be positive or negative 7, right? So you just do this. You set r plus 6 equal to positive 7 and r plus 6 equal to negative 7. And then you just solve them both. So we get r equals 1 and r equals negative 13. Now, I could have gotten those same two answers if we had done it the way we've always done it. Like if we had moved the 7 over, it would have been negative 13. And if we had done an asterisk for negative 13 and positive 12, I would have had 13 and negative 1, and 13 would give me negative 13, and negative 1 would give me positive 1. I would have preferred that method. It would have worked. But because they're telling us to complete the square, you have to do it that way to get the bonus points.
Okay.
Because otherwise, I'm just not even going to count that problem.
Could we do that just to make sure that we're right?
Yes.
Like, does it have to equal out the same, well,
Yes.
opposite of what we end with?
If I had actually gone all the way with this, I would have ended up with negative 13 and positive 1. I just didn't finish it. So yeah, like you could work it out with the asterisk and make sure they match to know if you did it right or not. Okay, now for the last one, vertical and horizontal asymptotes are actually not even all that difficult. Pretty simple, pretty straightforward here. What? This wasn't necessary. This I was just showing if you had done the asterisk in the beginning, it would have given me the same two answers. So you don't need that. That was just more like a check. Okay, so for this vertical and horizontal asymptote, to find your vertical asymptotes, you are supposed to set the denominator equal to 0. So this is for the vertical. So I have to factor it with a negative 3 and a positive 2. So two numbers that multiply to give me negative 3, but add to give me positive 2.
3 and negative 1.
Okay, so I'd have x minus 1 times x plus 3. So my two answers would be x equals 1 and x equals negative 3. Now I'm going to tell you, this one is just a weird case, but only one of those are actually the right answers, because if I had factored the top, if I had taken a negative 1 out of that, I would have had x minus 3 and x minus 1, and my x minus 1s would have canceled each other out. So this one really should have only been the only vertical asymptote. Most of them won't work out that way, so let's just say for now, like there's only one on your final. Whatever's down here, whatever expression is on the bottom, set it equal to 0 and solve, and that is your vertical asymptote, okay? Okay? Just set the bottom equal to 0 and solve.
We don't do the top one.
That's for the horizontal. So now for the horizontal asymptote, this is all you do. This is dealing with y. The rule states, so make sure you listen, that if the two exponents, like the leading exponents out here, if the top one and the bottom one match, so they're both x squareds, this is all you do. You put the leading coefficient up top, which is negative 1, divided by the leading coefficient that's on the bottom, which is positive 1. And what is negative 1 divided by positive 1? Negative 1. That is your horizontal asymptote. And that is the end of your practice final.